So that is how we build number. This place we spend a lot of time there, because the problem with 11 to 19 is that when you say it doesn't actually tell you what number you are trying to do. When you say 21, you can actually decode that it's 2 and 1. But for 11, 12, 13, it takes a lot of time for a child to understand it. But when we use this, it stays with the children. The children understand it. So there's no problem of 1 and 2 makes 12. 1 and 3 makes 13, so we don't have the problem. So when they can decode all this, the short bit, they know the colors, they know the numbers, then we start building this number one after the other. So the child do this up to 19. So when we get to 19, when we're going to 20, we know that it is 2 of this, which is because this is 10, this is 10. 2 tens makes 20. Then after finishing with, the child can build 1 to 19 on their own comfortably. They can count it. They know how to form the number. We go to tens, counting in tens. Now we only count all the tens. 10, 20, 30, 40, 50. That is what we do. Now, why do we do this? Because when child gets to 29, they start writing 20 again. Some children do that a lot. When they get to 30, they write 30 again. So, but if they understand the sequence, they counting in tens, 10, 20. So after getting to 19, we go to this trade-off. So the child already knows from building 1 to 19, from working with it frequently, they already understand that, okay, this is 10. So now when I get here, we just give the name to the child at first. This is 10. We call this 2 tens, 3 tens, 4 tens, 5 tens. And we also tell them, mathematician has 2 names for these numbers. They can call it 1 10, which is 10. They can call it 2 tens, which is 20. They can call it 3 tens, which is 30. They can call it 4 tens, which is also 40. But we make sure that they know the 1 10, 2 10 first of all. So now, this is 10.
Good morning.
So to help your child at home to do number 19, number 11 to 10, we make something into, you can make beads. All these, they are air beads. You could just put 10 in a row like this, so this child can see. You can look for the ones that the color, the golden color, and count them and look for just use strings to put them together. So a single bead, the child knows that 10 and 1 makes 11. So he adds another 1 into it, makes 12. So like that, they could build up to 20. So when they get to 20, take the loose one out. When they get to 19, you tell the child, when I add another one, that makes it 10. So now we have a 10 again. You take the loose unit out. You can use beads, buttons to make them. So when I take the loose bead out and make another 10 of this, show the child that 2 tens makes 20. So we do 2 tens makes 20, 3 tens make 30, 4 tens makes 40, 5 tens makes 50. So now when they understand 10, 20, 30, 40, 50 to 90, so we go to 100 board, because now the child knows how number move from 10 to 20 to 30. So we start to we introduce them to 100 board. Now this is the 100 board. So these are we make things that can help the child know how to these are things you can do at home with your child. So you can make their air bead into these single beads. Just get like 20, 30, 40 of it for the maybe a 2 and a half, 3 years old child, just for them to count. So then after making this, for them to now move from, now the child knows 1 to 20, can build 1 to 20, can give it the quantity, because you've been doing we don't do 10 plus 1 plus 1 makes 11. We do 10 because this is B10 and this is 1 makes 11. B10 and 2 makes 12. B10 and 3 makes 13. We use this word with our children. We don't use 1 and 13. 1 and 3 makes 13. 3 and 2 makes 32. Please, 3 and 2 makes 5. Because and in mathematics means addition. Yeah. So when you have 3 and 2, that gives you 5, not 32. So you can tell them 3 tens 2 units makes 32. So, but if that's why the language has to be appropriate. That's the reason why we're having this session. So when we're telling them something in school, they don't learn something else at home. So usually it becomes a struggle for the child. The child is confused. Mommy says this is 3 and 2. The student is saying is 10 and 20. So the child is lost between the way. So they get to school, they're trying to help explain it to the child doesn't get it. So, but if the school is doing the same thing, and at home you're using the same language, it clicks, the children understands it. So now we say this is 1 10, 2 10s, 3 10s. Now by just putting this, the child, this is 20, because this is 10, 1 10, 3, and the child uses up to 90. So when the child gets 90, and I tell the child, if I had another 10, that makes it 100. So now we introduce the child to 100 board. Now this 100 board is to help the child know the sequence of numbers from 1 to 100. So we've also made something that you can do at home. This is just, we printed number 1 to 100 in cardboard paper, and we cut them out. Now, instead of the child coming to school and counting 1, 2, 3, 4, 5, 6, so the child works with this every day, matches the number on something we also created. So the child, it takes a lot of time, which is good for them. So they help them understand the sequence of numbers. So we have what we call control of error. This is what you put, the child has this, and this plain one. So the cut out now, the child looks for the number and matches it by themselves. So when they are done, if it's a writing child, the child also copy that same number in a sheet of paper that is like this. So a child that works with this every day, they work with it once. By the time they keep working with it every day, without having to count number every day, 1, 2, 3, 4, 5, they already know 1 to 100. This is how we teach them 1 to 100 without reciting or chanting it every day. So the child understand because they've already learned 1 to 90. So they know that when I get to 60, the next number is 61. And the control of error is already there. So they follow this every day. So that is how they get numbers. So this is something you can also make for your child to do at home to help them with matching numbers. So from this,
I have something to say. For working with this number 100 board, it can be a bit tedious. So when your child starts, just start off with 1 to 20, so that you break it. It's called chunking. You break it in bits. So your child will do 1 to 20. Oh wow, you did this all by yourself. Do another 1 to 20. When that child is ready, of our own volition, she will carry the next one like, okay, where is 21? And especially after she has been given a lesson in school, she will do it. So it's a process, or else we get the children frustrated and they won't be interested in working with this.
So it's the reason why this has been shared into 5 boxes. The 1 to 20, 21 to 18 to 19. So from this in Montessori, we go to decimal system. We immediately introduce them to decimal system. We introduce them to the unit, tens, thousand, hundred, and thousand. Now, this is to help the children see how the gradation of number. Now, this is unit 1. So when I have 10 of this, it makes 10, which the child already has been saying from making 11 to and making 19. So when I have 10 of these units, it makes 10 of 10, and it's called, the bit is called 10. So when I have 10 of these, it makes 100, which the child has been doing, but probably would not give the child the name for it when it's together as concrete now. So now when I have 10 of these, it makes 1 of this, 1,000. So now we give the child the name. Unit, 10, 100, 1,000. So we give the child the number. Unit, 10, 100, 1,000. And you can see that they are color coded. So the child also treats the child in colors. So the unit is in green, the 10 is in blue, the 100 is red, the 1,000 is also green. Now, from here we can start doing addition. We introduce them to operations. So we show them numbers. And we spend a lot of time here. Because the reason is that Yes, they know the number. Now the child must be able to build. We must build 1 to 10,000 before we leave my class. The child will lay out a rock and we build one on their own. Lay out the numbers, lay out the quantity. A child can use the whole day to lay that out. Because you can imagine a 4-year-old child trying to lay the number from number 1 to 10,000. It's a very challenging, right? So now, after they've gotten that, now we do what is called bring me game. So I can just get the child and give the child a series of numbers. I could say, oh, can you please get me 1,555? I'll give the child the tray. I give the child the tray and say, can you go to the bank? Go to the bank, get me 1,555. So the child should be able to give me one of these, 500 of 5 of these, which is 100, and 5 of these, and 5 of the units. So now this is not time. We don't rush it, because what we want is for the child to understand the numbers, be able to give you the numbers. So we do a lot of games. So we also have when the child is very, they know it very well. So we do a lot of games here. So this is also color coded. This is the units, the 100, the 10, the 100, and 1,000. So the child can play this. Oh, 3. Can you get me 3 units? Oh, 10. Can you get me 10? 100. So the child must give you the quantity. So we give the quantity for numbers, and we also give the quantity, the numerals, the quantity. The child must be able to give. So we spend a lot of time. And so when we introduce them to operation, we can do addition. Then we give them cards like this. So when I say I give them numbers, I can give them this. So that is 8,437. So the child gets a tray, go get 8,000, which I've laid out here. 8,437. The child goes to the bank and gets it. So now it's my duty to make sure I count it. Okay, if the child gets it wrong, please can you go back and get it the right way? Can you go back and get it? So now I can give the child this card. The child gets all this quantity and add them together at the end of it. And at the end of the day, they record it. So a 4-year-old child that is going to 5 can do addition to 9,000, even at 4. Because of the understanding of numbers, it is not challenging for them. So they spend a whole lot of time here to understand the gradation of number, really the quantity. We will do a lot of, you'll be seeing in their report, bring big game. We are either doing one of either the number, the quantity, then we start doing addition with it, and they record it. And even the book also already has the unit thousand, so they know where they are recording it. So now, what this helps the child is that when we're doing place of number, place value, whereby maybe here I have 4, 7, and here I have 5. So the child understands that the math is also color coded. So the child understands that when I get to 10, I'll take this back, 10 of it back to the bank, and we come back with one of this. And this goes to the 10 area already. So the child can see it. It's not, oh, just put the one there, the one, just carry it there. No, the child can see why they're carrying it, because, oh, you can't put the 10 in the unit area. You need to take it from the unit area to the 10 area. So they can see that it moves on its own. So that is what this does for the children. It helps them see how number is great, why numbers are carried from the unit to 10, from the 10, why do they carry it? It's because it is 10. When it's 10, it cannot stay in where they are. They have to move to the other gradation of number, the bigger one. So they carry it on their own. So that is why we do it. Then we go to, this is operation. Then we go to 5. Now 5 is helping the children on their own. They could tell 2 plus 2, 1 plus 1, 3 plus 3. It helps them understand that why do we have all of that. So we have different materials that we use. so that the children work with different things, they don't get bored, and it stays, because when you keep seeing something, you know it. Now, this is called the small number rod. This is called the number rod, the small number rod. We have the big one here. This is we would have introduced this in the first place. So the small number rod, this is rod 10, and this is rod 9. So now I want to build, I'll first of all build I'll build all the numbers that makes 10. 9 plus 1, 8 plus 2, 7 plus 3, 7 and, sorry, we use and first. 7 and 1, 7 and 3, 9 and 1. So this is 10. This is rod 10 and this is 9. So this is rod 10 and rod 1. Rod 8 and rod 2 also makes 10. Rod 7 and rod 3 also makes 10. Rod 6 and rod 4 also makes 10. Rod 5 and 5 makes 10. So the child can visually see all the numbers that makes 10. I have another material here that I use to make that. The child just using something else to make, the child can see all the numbers that makes 10. By doing this every day, by doing it continuously, the child knows, can tell you 10 plus, can tell you 8 plus 2 is 10. Because if you're doing it every day, they're seeing it, they work with it, they're touching it every day, they know it. So this is why they do fast, so that they have that 2 plus 2, 1 plus 1, 1 plus 3 on their head without having to use their fingers to count or have to use counters. Of course, this is not immediately can we get there, but continuous work, they get there. So, agbalumo seed it's a beautiful instrument. I remember using them when I was younger, so I love them. So, those are the things you can use at home. So, the colored bead also, that we've been using all this while, the short bead stems that we've been using all this while to do the 11, 19, 20. So, we also build them here, and we also use it for addition. 1 plus 1, 2 plus 2, 3 plus 3. Now the child, we have simple addition like this. The child works with every day. This is 2 plus 2. This is 2. Addition of 2. So 2 plus 2, 2 plus 1. They do it. So by the time the child is doing this like the third time, the child will know that 2 plus 1 is 3. After doing it for 3 or 4 times, the child knows. So it's registered. After working with this with a lot of time to doing this and doing this, they already know. So this is how we do fact to help the children know number, because when they get to elementary, this helps them to do the much bigger work they're going to do in early. So, and also in my class before they do multiplication. So we can use this bead that's been set out here. You can wonder why a 4 years old child will be able to do 770,000 times 3. Because all they have to do is get the 744,000 3 times. You just get it 1, 2, 3, and they add it up together. Because addition, multiplication is repeated addition. So if I have 544 40 times 3, all I have to do is get 500 the first set, the second set, the third set, then stack them up, pile them up, then I count all the beads that I have there. So they do multiplication before they leave my class, and they don't just do 2 plus 2 times 1. They will get there when they're doing fast, but they do it with the golden beads, and they get it, they understand it, because the materials are concrete. So here we don't move them into abstract. Everything we do at this level is concrete until they move to early. At some point they're going to abstract it. So she is going to explain how they get there today. So thank you.
Well done, Sonia. Good morning, parents. I've explained it. There's a reason why we're doing it sequential, because she does her job well, makes my work easier. And so she says, for operations, now in math we have different areas of math. We have math operations, we have math facts, we have math exploration. They're doing it as well, but sensorial. Now we also have math geometry, all of that. The differential we still have what today. Now all of them have different purposes. Now Ms. Tonya would do and work with the children. If you notice, the materials are a bit different because of the nature of the child that they're dealing with. Her children are younger, they work better with movement. So the bring me game is go and bring me that they enjoy it, they love it. When they get to this level, we are a bit more mature. We like to have our own space. So the materials become smaller. They don't become, as in they are no longer as large as possible. They don't require them to move from one place to another because the nature of age group I'm working with, they find it a bit clumsy or bored and everything. So she's going to work with the golden beads, which require them to move a lot and stop at multiplication. So if she stops at multiplication, I'll go ahead and do golden beads and introduce the concept of division so that they understand the concept of division. But once I'm done with that, I go back to addition with them. Now this time with the purpose of helping them abstract. They can't work with materials everywhere. If they go out and they ask them with 9 plus 5, they don't have the materials. So my job is to make sure that they abstract all of those things. So the materials are good for them for the age. As they come up, you take it a bit away, and you take it away from them. And that's my job. So I will go ahead and use the golden beads and introduce the concept of division. But then I go back, after I'm done, I go back. This time around, start off with the stamp game. The same thing, place value. They are color coded. This is unit, 1 unit. This is 1 cent, 100, and 1 decimal. But this time around, we're no longer counting because with what we see, they have internalized it. So we just want to go ahead and enforce what she has done. Now, I go ahead and when I go back to addition, we use this. While they're working with it, it helps them to internalize what she's done, place the values and all of that. I do addition, I do subtraction, I do multiplication, and I do division. But then I don't take it at once. If I'm working with addition, I take addition. We run through all of these materials are for the same purpose, but then to give them variety and then to also help them abstract, because this requires them to take. But this requires them to just bring, this is 1 unit, 1 cent, 100, 1 business. So I ask them 2,536. So they just bring it out. This is 2,536. Yes. Plus another in addition is add them. Now that's another thing we work with them. We try to give them the concept, the name of the for instance, in addition, when you're adding 1,536 plus 2,500 maybe 30, we tell them that the first number you call that is the first added, the second one is the second added. Now the answer in addition is the sum. Why do we do that? Because sometimes you go for a test and they ask the child to say, the question is, what is the sum? They don't tell you add together.
Right.
So if they are familiar with those concepts, they know that the sum, once they hear sum, they're asking you to add. Now the same thing with subtraction. The concept in subtraction is the big number that you're taking away from is called the multiplier. And then the number you're taking away is called the multiplier. Sorry, it's called this minuend. The subtraction is called the minuend. The number you're taking away is called the subtraction. Now the answer is called the difference. In most exams, you hear them say, what is the difference? So we use those things. And I also want for parents who are going to work with the children, please, as much as possible, learn the words and use them with them, because in the long run, it's going to help them. For multiplication, the big number is the number you're bringing out is called the multiplier. The number of times you're bringing it out is the multiplier. Now the answer is the product. You also know that most times they tell you find the product of that number. So we use those terminology. Division, the number you're bringing out to divide is called the dividend. The number of times you're breaking it into is called the divisor. And then the answer is called the quotient. So let's keep that in mind. Basically, this is operation. That's what we do in operation: addition, subtraction, multiplication, and division. So this material is called. The first one is the stamp game. This is the small big frame. This is the large big frame. This is ideally where I should focus on. because this material, first of all, introduced as a both the historian has worked with them to thousands, but I'm going to extend it up all the way to millions. And this is the first material they're going to use to know the family of the numbers. Now, with this material, if you look at it closely, you see that the first three place values are together. There's a bigger space between the next place. So it's more like dividing the numbers into families. So you teach them that this is a single family, this is a hundreds family, and this is a millions family. And as they go further, they'll take it up from millions all the way to whatever the upper elementary wants to take it. But the essence of this is, you can give them any number. If they understand the family progress, if you give them any number without even putting the commas, they should be able to group it, because every family has three numbers. The first is the unit times, and that's called a simple family or 100 family. Now, if I give them a number randomly and I just write 5, 6, 7, 8, 9, 10, please call it for me. If they know this, they'll be able to group that number starting from here and call it for me. So it's a beautiful material. We use it for, try not to, because by the time they get to this material, they basically abstracted addition and subtraction. So we may not use this for addition and subtraction, we use it for multiplication. Now this material can be used for double digit and single digits multiplier, meaning multiply by 9, and I can also multiply by 30, by 45 using it. If I say I will do that now, it will take a while, but maybe for parents that want, after we're done, I can sit down with you and actually do it and record it and see how it's done. Now this is also this is called the checkerboard. It's also used for multiplication. Now it's also used for large multiplication. What I have here is 23,874 multiplied by 61. Now this material, we'll do the same thing this is doing, but in the long run, it's teaching them, as in the aim of this material is to help them cross multiply. Like if you're multiplying with two digits, you have introduced the child to the fact that when you're multiplying by tens, you add 0 to the end of the number. So basically that's what this material helps with. If I was to set it up, I'll set up the multiplier this way, and I'll set up the multiplier this way. Now, they'll put the values of these bits. For instance, if I say, let me bring out this is 23,000. So if I put it in the place of 1,000, 10,000, it becomes 2,000, and then 20,000. So if I put 3 here, it becomes, this is 3,000. Yes, 3,000. So I lay it out like that. According to, for instance, this should have been two 10,000. This is 3,000. This is 8,000. This is 7,000. So this is 800. This is 7,000, and this is 4 units. Now multiplication is basically just bringing that number, the number of times the multiplier tells you to bring. So in this case, it says they've worked with it here, but this time around is 61. Are you going to bring out the stamp? This is 61 times. No. So the materials are built to help them do that. If I was to set it up, when I can't do this, it should take a long time. But maybe afterwards, I can do like something for you. So
Example.
Yeah, example. So basically, what I should do is so that you see how it's
Yes,
multiplied.
please.
Let me just bring it out. This is 2. This is 3. Sorry? I'm sorry. Just corrected me. In an ideal situation, I shouldn't build from this way. I should build
Right,
because
from
of the way I'm sitting and the
units.
fact that it's
Adult.
so I bring out 4 units. But before I even do that, I have to set up the multiplier. This is 23,000. 23 is a 10,000, so it's blue. The white tiles are for the multiplier. So I'm going to bring out 2. And I'll bring out 3. Bring out 8,000.
Right.
Should I move it to the middle?
Yes, probably.
It's not my copy. Okay, apart from my multiplicand, it's 23,874 multiplied by 61. Now what I'm going to do is I'm going to bring out the value using the base. This is 4 units brought out one time. So I'll bring out 4, brought out one time. Now for us to, because I'm not working with the second multiplier and cover it. This is 7 times brought out one time. 7 times brought out one time. And I put it in the value of 7 times. This is 800 to be brought out one time. This is 8 days. I'm bringing it out one time. 3,000 brought out one time. 3,000 brought out one time. 2 10,000 brought out. 2 10,000 brought out one time. Okay, so I've laid the first part of this equation. It says 23,874 to be multiplied by 61. This is the unit. So I brought it out one time. I'm going to bring it out using the times. So I bring it out. The times says 6 times. So I'm going to bring out 4, brought out 4 times. 4 brought out 6 times, sorry. 4 brought out 6 times. 7 times brought out 6 times.
I think this is perfect actually.
And I didn't want to go ahead and just add them so that you see why it's going. 7 brought out 6 times. 1, 2, 3, 4, 5, 6. I'll do it again. 800 brought out 6 times. 8. 8. Sorry.
Let's take the first one.
8. Okay, this is actually 9. I apologize. Sorry. 1, 2, 3, 4, 5, 6 times. 3,000 brought out 6 times. And then 2 10,000 brought out 6 times. 2, 3, 4, 5, 6. 3,000 Now, it depends on where the child is. If the child has learned his facts or has understands, has knows his multiplication facts, he may not bring down all of this. He will just bring out 4 times. He will just do it, go ahead and do it 4 times 1, and just bring out 4, 7 times 1, bring out like that. So it will be easier. But for the child that is just starting, we may do it this way. Reason being, since he doesn't know his facts, he can just go ahead and count it. And so this is multiplied by 1. I don't need to change it. So I will just go ahead. 4 times 6. This is 4 brought out 6 times. So I'll count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if the child knew that 4 times 6 was 24, this one would have been easy. You would have just brought out 2 and 4 and put it in the place values. But if the child doesn't know, you can go ahead and do this. So it depends on where the child is. So
that can skip counts also.
Yes.
You have 4 then. That can skip counts in 4.
Yes.
4, 8, 12.
Exactly.
That's the process. From counting the days, when you skip counts, when you bring the facts.
So I bring out 24.
2 times. 24 units.
Now I brought out 24. In 24, you must have known that when you're writing 24, 4 is the unit, 2 is the times. And that's exactly how you're going to place it. I put the 4 here, and then I put my exchange up here as 2. So in the how we were taught is you write 4 and then carry 2 over. But in this case, it's the same thing basically, but they are saying it and they're saying why it's
Being carried over.
so 7 times 6 is 41. I'm just going to go ahead. I want to count down this. Plus 2. 43.
44.
40.
44.
43, you're right.
Okay. 43. How am I going to put it? 43. So I'll make sure I put 3 in the place value. So
And then
I'll put
carry
this
over
one
the
in the
hundreds.
place value. This is 8 times 6. How many times 6? Is that 48. 48. Okay. Plus 4.
52.
52. Sorry. I'm a good mathematician. I think that's a good test. So 52, right? I bring out 5 and 2. And I make sure I place it where it should be. And then 3 times 6 is 18 plus 5, 22. So,
23.
23.
18 plus 6.
18 plus 5.
Right.
23. Then I count 2 of this. This is 2 times 6, 12 plus 2, 18. 40. Draw with me. 14. That would be 1 and 4. Okay. Now these are the ideally still depending on where they are. If they are at the third level, I will explain to them that these are fashion products and then they record it. I teach them how to record it. But for this at this level they haven't gotten to that. So we teach them just to slide down. We use the glue to slide down. We slide down using the columns. So this will go here, this will go here, this will go here, this will go here, and this will go here, this will go here. When you add it up together, it's what you so it makes double-digit multiplication look easy. And because they are saying it and they are work with it, when eventually they want to do it absolutely, it's more like easy.
Automatic.
You go ahead and add it up and record the answer the way it is.
And then you know the reason why you have to give the space.
Exactly.
When we were growing up, they'll tell you
Just
leave
with
the space.
zero. Exactly.
Or you put zero. When you are older, they tell you leave the space.
Exactly.
But the older sense is when you multiply a 10 with a unit, the answer can never be in the unit place. It will be in the tens place. So that's why you have that zero or that space. When you multiply with 100 times units, your answer will be in the 100 space. So you leave two zeros or two spaces. So that's the whole essence of this word.
Okay, so this is what we have represented the facts. Now, in the elementary class, like I said, we are all about, the goal is to help them abstract. So, if I was to introduce the concept of multiplication to the children, this could have been done alongside when I started this. And that's the beauty of Montessori. I'm doing this introducing the concept, they're working with the operation, at the same time they're working with the fact side by side. So if I'm introducing the concept of having, like, for instance, this says, this material is called the big value. And I teaches them basically multiplication.
Thank you.
Now, it shows them clearly what it is. They said, build a set 1 to 10 times and write your equations. Check your work with the control chart. Now, this is a set of 4. So I'm going to build it. It's more like multiplication, but I'm going to bring it out. So you bring out 1. 1 brought out 1 time, we give you what? 1, 2, 3, 4. You put it on that side. Now, 4 brought out 2 times, sorry. And then they count. It's 8. So they go ahead and bring out 8 and put it by the side. 4 brought out 3 times will be 12. So 12 is 110 and 2. 4 brought out 4 times will be this.
Right. So rather
So
than
instead of making a
writing
child
multiplication
1
table.
6. Before the child goes to times 1, 2, to times 3, the child has worked with it. The child has manipulated it. The child sees what is going on and memorizes it. So it makes it easier for them to understand. So they get to work with this for different numbers. And as they're doing that, the teacher is helping them enforce, please memorize it. Please memorize it. So it's not just root counting 2 times, 1, 2, 2 times. So they get to see it and they understand it before they eventually memorize it. They keep working with this and doing drills on the side, as in once in a while you put them up, give them a test, right, as in tell them, give them a drill card, and that has different multiplications, equations together, and they sit down and they do it. Eventually you time them and make sure that they admit, the more they work with it, it gets better with them. So basically that's some of the things that, yes?
What's the material called?
The bead bar layers. Bead bar layers.
Is this for
Multiplication.
Now for the essence of this is to see how you guys can work with it at home. I think basically you just need to get a jar of whatever it is, whether it's beads or buttons, for them to be able to do this if they're going to work with it, so that if they're not abstracted the concept, they don't struggle with it. Really. But we wouldn't give homework in math till they have abstracted the concept. But just in case you want to work with them at home, this is what you can do. Just get a jar of beads that you can use, and maybe a rug or a space for them to be able to lay it out and calculate it when you need to do it. Thank you. I hand over to Mr. Berry.
Okay, good morning, parents.
Mr. Berry.
I want to start.
Okay.
That's fine. Now, as we keep moving, we're getting to 9 to 11 years. That's why we have the upper elementary kids. This place where we're doing division, sometimes we have equations everywhere. when we talk about this math problem, I would say long division is a very difficult thing for parents to do. When it comes to long division, like find it, what can I do? Some children get confused when they do long division. And if you permit me, I want to solve out one problem. This is called test tube. We use this test tube for division. It's called test tube because the beads are inside tubes. So like, if you look at this, like a test tube used in laboratories, right? So because they're laid out there, and following up the whole process, you notice that they're all in colors as well. The units, the tens, the hundred, this is the simple one that you showed on this board. The simple, see, it's white there. And then the second one here, we have the hundreds, and then we have the hundred, the tens of, the thousand, the tens of thousand, hundred of thousand, and then the million. We keep adding according to that way as well. So these things are called the test tube boards. We use them to share. And then we have the skittles inside there. These are called now we have the, sorry, this is supposed to be here. Then we have the skittles as well. This is what we use to divide. When we're dividing, the green goes into green, and then the blue into blue. What if I have a number that has, like say, dividing with double digits? If I use this 2. If I'm dividing only with 1 digit, because if I divide with 1 digit, I use only this green one to divide, and I use the skittles. As we had earlier, the 4 here is the divisor. That's the one dividing. And then the dividend. For instance, I have this question. I write out the question here. Say 4. I use this format. Okay. Okay. This is my question now. This one is dividing this. And most times, long division, at this level, we call abstracting. We want children to work not just with materials, but to work here. Can use a paper, they see the question anywhere they can handle it. Because if you only go with materials, sometimes you give them a question, they don't know what to do. So here we use, in the classroom, most times we use boards. We usually work with this. So as you are you're working here, you're writing it down before you copy it down into your notes. So here we have this question. This is my divisor, I said this is the dividend. My quotient, the answer will go up here. And as the rule of this said, if your divisor is bigger than the first digits in the dividend, then you can share. But if not, take 2 numbers at the same time. But at this point, if you notice, 9 is bigger than 4, right? So but before I divide, I have to pull out my materials. Now I have, in division, other places we do start off without laying with from the unit size. But in division, we start with the highest one, the biggest side. So I have 1, 2, 3, 4. 1, 2, 3, 4. So I'm getting to the 1,000 now. So I'll start my 1,000. This is my cup. How many do I have in 1,000? I have 9. In all of these, I have 10 bits. So I know exactly that if I remove 1, I have 9 already. I'll take out 1. So my 9 is here. I'll put it back. Then what the next number I have? 7. And it's under my 100, right? So I'll go to the 100 bit. I take away 3. I bring my cup. Cup stays here. I remove 3. Then the next one is 6. This is my 10s. I bring my cup. The blue is inside. I use my blue beads. And it's 6. And finally I have 9, the unit side. I use my green, it's green inside. So I take away 1 as well. I pour all this in here. So I'm set to share. Hold on, I have my skittles. Now I use this to represent the people sharing. Let's say my device will say 4 people are sharing this number. So these are my schedules. I put 1 person, 2, 3, and 4. I use green because it's the units. 4 is just 1 digit. So it's units. So I use my green to share. Now I want to start with the biggest number. I will give each person, they must get equal share. I keep giving them out. So I start. I have 9 here. Let me see how many times it will go. Those that are very okay will know that 9 can go just 2 times in 4. But if I'm learning, I pick one by one. I don't want to rush it. There are holes. There are holes inside this board. So I'll just drop the bits inside there to go in. So I have 1. I have 2. They've gotten 1 each. I want to go over again. Oh, now I have 2. That means I come back here. 4 dividing 9. What did I get inside now? 2. My quotient. On top of this place, I write 2. But I think 1 is remaining in my box here, right? And it can't go because there are 4 people. So what do I do?
Reduce it.
I need to do what?
Reduce it.
Normally we put it here, right? We'll put the 1 here and say it's 17 will go. So with this my bits, what will I do? So what I do now is to look for the next one, the one lower. And which one is that? I have thousands already. So I'll change this my tens, break it into the lower one, which is the 100. And this one, 10 of this
We'll make one
will
of
give me
that.
1,000.
Right.
10 of 100 is 1,000. So I have to share 10. Now I remove this. This one goes back because I'm exchanging it now into my 100 box.
You're green.
And I place it down because I've emptied it so that I don't get confused at all. And I continue with the work again. I begin to share. I continue sharing again. See how many times I will go. Oh, I got 4 again. 4 is 17. Remember I have 1 left that I shared. I added 10 to the 7 I had, making it 17. So I got 4 again. 4 is 4. I got 4 in this one. Then I write my 4. But I think I still have 1 inside my plate. What do you think I should do now for me? To exchange with the 1 next. One of the 100, 10 of the 10s will give me 100. And followed here, 10, 10, 10, 20, 30, until get 100. So 10 of this will give me 0. So,
Since you're doing long division, you need to show your work.
okay, the down part. Alright, so then when I got this one, the 1, so 4 times 2 usually go that way. And I put the arrow to go down. 4 times 2 will give me what? It will give me 8 as I go here. So I'll do 8. 18 here, then subtraction. That 1 that I had, the 1 left, takes down here 1, and then I bring the arrow down, bring in the 7. That's why I got 17 down here. You understand? I'm sorry, I didn't show it on the board. Now I'm going to the next one. So let's subtract 4 times 4 will give me what? 16. So I write 16, and then I take away. So if I bring it down to main 1, 19 down this one. So what I have here will be what? Breaking down the next line. But a child that gets low might not want to use this arrow, just bring down the word because it's used to it. Then I change this one again to my 10s. One of this code is 10 bits, so I exchange it with this, I return this, and I put this one. And this one is this. That's how I will continue until I finish dividing the row. So that way, the child needs to get to know that when you divide, it's like 3 steps. You divide, you multiply, and then you subtract. You keep going. So not just using the bits, but also using If he sees this anywhere in question, he can do it without just waiting for material to go. So here we do a lot of abstractions. Okay, if I keep sharing all this, can I finish?
Can I say something? The kind of division that she just finished is called distributive. For those children that are just starting to divide, you do distributive. Distributive means whatever quantity you have in your bowl, just share it. And along the line, when the facts start coming in, and you look at it, it said how many sets of 4 is a 9. And there's a lot of in-house games which you need to share with your parents and the children at this time that they can do. It's called grouping. A lot of games you can do. Like we're here now, I want to start the lesson on group division. I can look at everybody and say, can we be in a group of 4? How many group of 4 do we have here? So if we put ourselves together, 1, 2, 3, sorry, 4, we're actually 16. So we have 4 sets of 4 in 16. So it's a game you can play with your child at home, or you can use beads. Let's play again, Let's put all these beads or buttons down. So it's a game you can play in preparation for group division. And when it's group division, it makes it easier for the children to share. This work is very tedious. And all they want to do is to abstract it and move away from it. So you see them, their brain is like, how do I do this? How do I do this and get off this? Which is where we want them to get to. But they don't know. That's our goal, that get frustrated and get off this material. So group division is the last set. By the time they start doing group division, they can
Everything
do it
is
without the
abstracted.
material.
Thank you, Mr. No, thank you very much. So as we are saying, if whatever we get, it's only the unit that tells what your answer will be. I might use the tens if I want to do double digits. But whatever I get here, this is only my answer here. My quotient comes from here. This way just a support to help do this. Even if I use the 100 plus 2, I look at whatever I get here. That's where I get my quotient and I put it back. So what each unit gets, each unit board gets, person gets, each one gets that 2, I said 2,400. We keep moving until we are done to get to the unit part. So whatever I get here is what the answer gets. So if I finish all with my 2 plus 4, I can move on. Okay. Oh, it's clear, right?
Yeah.
Okay. So moving on again to decimals. Actually, when I was growing up, decimal is one part that I don't like playing. I don't like working. It's something that, you keep working with normal numbers all the way. Now you're coming to 0 upon 0 and all that thing. But when I started working with this, I saw it as the easiest part of math. You might ask why. It's the easiest. The way it's broken, the way it's explained makes the work very, very easy. See that decimal is like, everybody wants, the kids after everybody, they want to work with decimals all the time. I don't want to go back to other ones anymore. So this is the board, decimal board. This is the board we use for decimal. This is divided here, there's a line here. So these are the normal unit numbers. We have our whole numbers. These are whole numbers here. Starting with the left, the units, the tens, the hundreds, tens of thousands, thousands, tens of thousands, hundreds of thousands, and a million. But these are the decimals. If you notice, the colors keep fainting, keep going fainter and fainter all the way. So we use our beads too. This is what we use for decimals. The way it's also arranged, the colors keep going. This is the darkest one, and this is the tens. In normal number we say tens, hundreds. Here we go tens, we go the hundredth, adding the th and the gth all the way. We keep moving. This is darker. This is darker red. If you notice here, it's darker green. Now the blue is getting lighter here. The red here is getting lighter, and this green is getting lighter too. So that's the way it keeps descending, getting smaller. And those are the cards that go. These are the cards too. These are unit cards. I have 1 to 10. I have to lay it down to see. 1 to 9, I think. So we use it for the unit side. If I want to do any tens, 100 and all that. But these ones are the decimal cards. You see 0, 1, that means no units in there. The 0, 1, the 0, 2, and all the way to these are the tens, the tenth, the one. There's no units in decimal. The decimal is the center. It demarcates the whole numbers from
The fractions.
the fractions or the decimals. These are also fractions, really. So we break them down, we work. So anytime we want to work on this, we use these bits. This one also helps us, and as we also work with them, we try to abstract as well. The kids that I say, we make use of these boards a lot in class. Before class, don't make mistakes. Understand it very well. You have the bigger boards, you have the smaller boards. And they get used to the concept. Everything they've been learning all the way, we come here, they practicalize it. We add decimals, we multiply decimals, we divide decimals. And if I can show one, we also subtract, add and subtract as well. I don't know if I can add up one. Do I have the time? No time now. So that these are the things we do. So the number, the hierarchy, no time. We're starting off all the way. But we do that.
The people that are already here should
Is there one?
stay back. I said the people that are at this level should probably take a separate
Extra time.
course.
So when you need maybe to explain more, but people have been standing here for a while,
Exactly.
so we have to let them know. We also do fractions in elementary.
We're still at that level.
We do fractions here as well. But we do also in lower elementary. Keep moving up. Keep moving up until we get here too. So decimals are also fractions. They're not up to 1. And fractions, they are part of the whole. They're not also up to 1. That's why you see them together here. And they all here together. So fractions, we add fractions, we subtract fractions, we multiply fractions, and these are the pieces. Each of this is a whole, just one. The child is like a whole inside. Then this is half, a part of a whole divided in 2. So each of the cards here have the name on it. We have it up to 10, we have it to 20. One page. Child will see the difference between the sizes. Look like this one is bigger.
That's amazing.
To also help them to grade things as they go. Now this 1/4 is smaller than 1/3. As they keep going, if you want 20th, it's like the littlest, it keeps moving all the way. So whenever it's time for them to solve out any math problem, using 1/3, 1/4, 1/5 or anything, they just go for that. They practice in class and they learn how to use it. They can also subtract whole numbers from fractions. So these are the things we do here. And then
All abstract.
okay, sorry please. We have these two only that still I don't have the other. We have this two. This one is called the pegboard. The pegboard. I think how many of us can do LCM? I mean, it's kind of hard, right? LCM, is it hard? It's not hard, right? What about
For them.
Yeah. It's easy actually.
HCL, what about HCL? Z is it too? The height will be GCL.
Highest common factor. Yes.
So we use these bits. If you get in the name, say LCM, the lowest common number. So we'll look for the multiples of a particular number. With this pegboard, I can get the multiple is like successive addition. Add 2, multiple of 2 is 2. The next is what? 4. The next one is what? 6, 8, 10, all the way. So I get the multiples of a particular number. I get the multiple of another number. So what should be common between if I have, let's say 3 and 6, the LCM of 3 and 6. So I have to lay them out. We use any color. If you choose one color, I choose one. I will lay out. I use my multiples and lay them. These are the bits we use for them. The same color code. We have the green, we have the blue, and then we have the red. We still use them color coded to one. So as we finish, we'll lay them out and find the common multiple. Wanted to like show off one or two of them, but the time is really against us somehow. Okay, the simplest one. Okay. I'll see 2 and 8. So I want to look for the common multiple of 2. And and 2. I choose this, but we are big 2 here. I don't have a paper, we are writing 2 on top of it. This is my 2, and then the 3. I choose this line. That's about 2 and 3. Let's see, remember the setup again. Okay. Now this is 3, I'm moving 2. So the next one will be what? Multiple of 3 will be what? 6. I keep going until I keep, wherever I find, lay increase. I lay. I forgot to use. No, the laying. It's funny. Okay. So I keep laying wherever. It's called out from laying with that.
So I don't understand.
Laying right hand is the multiple.
Yeah.
So if you put 2 more there, then 2
Yeah,
times
down,
3,
yes,
exactly.
Yeah.
And 3 times
Yes.
2,
So
that's
3.
exactly.
We have 3.
Yeah, that's right.
Then another
And then
one.
2 in the, yeah, exactly. Yeah, that's right. So it's 6 and 6.
Yeah. Is it? So where they meet is this. If I continue, this is over here. Do you have a ruler? Over here, you can see that they are the same level. If I continue, 2 will be 8, and sorry, no,
One line of 3 needs to go.
no, it's linear.
Right, exactly.
2 taken 3 times, 3 taken
Yeah,
2
now,
times.
so, okay, this is 3 times, 2 taken 3 times, right? 2.
Yeah.
Then you make another set of 2, another set of 3, until when they get to 6, they will see that 2 of them are meeting up, and they will get to SCF as well.
Turn it, turn the 3. Turn the 3.
This way, lengthwise.
3 taken 1 time, 3 taken 2 times. So that's it.
Anyways, but we use this for, for that. Just that.